Hi, it's Alan from Crashtest Security. In this video, I will tell you more about JavaScript security and risks. So let's get started. As of 2021, the JavaScript interpreted programming language is estimated to be used by over 95% of websites. It owes its popularity to its omni-platform capabilities, stable frameworks, and inherent ease of use. Through JavaScript, organizations can develop the backends and frontends of dynamic web pages that offer enhanced user experiences such as animations, activity tracking, form submissions, and more. While JavaScript continues to be a popular programming language for web application development, JavaScript vulnerabilities are widely exploited by attackers and malicious users to manipulate data or gain control of web systems. As a result, it takes a focused approach to tackle security concerns that involve activities undertaken to detect, investigate, prevent, and solve such vulnerabilities. The growing popularity of dynamic web applications built on JavaScript introduces several security issues that can make applications vulnerable. These include the following: source code vulnerabilities. JavaScript developers typically rely on integrating numerous public or open source packages and libraries containing hidden vulnerabilities and exposing security issues within the source code. Open source vulnerabilities might not be easily recognizable at first, and using a vulnerable package expands the attack surface of your web app. Unintended script execution. JavaScript embeds functions on HTML web pages when interacting with a web page's document object model. Attackers can embed scripts into these functions, then execute them by all client computers that connect to the web page. Exclusive reliance on client-side validation. Most organizations only ensure validation on users' browsers. Though this offers a certain level of security, hackers who use advanced techniques to send unverified data to servers can corrupt records and configurations. Exposure of session data. Attackers leverage the power of client-side browser scripts to access all communication between the browser and the web application. This communication may include sensitive session data, such as user session IDs used for unauthorized access. Unintentional user activity. Attackers may use several techniques that manipulate a browser into performing malicious activities on various websites users are already logged onto. Additionally, hackers take advantage of security gaps in JavaScript that execute threat vectors on other sites in the background as soon as a browser is logged in. JavaScript vulnerabilities you must know about. Attackers commonly use well-known JavaScript security vulnerabilities to navigate through security loopholes of an application's attack surface to compromise user and system data. As a result, they often show up in a security audit report generated by a security scanner. These vulnerabilities include XSS JavaScript. Cross-site scripting vulnerabilities involve a code JavaScript injection attack from the client side. Where hackers embed malicious scripts on legitimate web pages, the application passes unvalidated data to web browsers. Web applications that factor in unfiltered users' input in the generated outputs are most susceptible to cross-site scripting attacks. XSS common attacks or potential vulnerability can be prevented through filtering and sanitizing user input, using effective response headers, encode data before output generation, utilize content security policies, using regularly an XSS scanner before very release, cross-site request forgery. CSRF is a widespread security vulnerability in which threat actors manipulate legitimate users into submitting malicious requests to web applications they are ambushed to visit. When the web application fails to differentiate between valid user requests and forged requests, attackers can execute any malicious actions under the guise of legitimate end users. CSRF attacks can be prevented by implementing secure random tokens, logging off unused web applications, disallowing automatic password entries by browsers, securing session credentials, using regularly a CSRF scanner before every release. Server-side JavaScript injection attacks. This mechanism injects and executes malicious or arbitrary code on a web application server without sanitized and filtered user inputs. Attackers typically look for functions that parse user-generated data without proper validations to ingest insecure scripts to be executed by the server. Server-side injection attacks are typically prevented by properly validating and filtering user inputs. Client-side logic attacks. JavaScript engines are known for their speed and performance for client-side processing. However, when organizations place sensitive operations, such as hard-coding usernames and passwords, the user can fully control the environment where logical decision-making is performed. This allows attackers to gain quick access and control of the web app through a browser. Client-side logic attacks can be prevented by avoiding operations with sensitive security controls on the client side. And when securing API keys in a client-side JavaScript application, the most commonly used option is to set an API access and secret key pair. Some best practices to keep JavaScript applications safe include: avoid evaluating user input, the evil and new function. Command executes arguments passed in user inputs as JS expressions. As hackers manipulate user input to run malicious scripts, it is recommended to avoid evaluating user inputs or parsing JSON data through the above constructors. Enable TLS/SSL encryption. Encrypting data between servers and clients helps prevent CSRF and XSS attacks. Secure API access. It is essential to assign tokens for each user accessing the web app through the API, enabling secure access. Setting secure cookies. By setting cookies as secure, each cookie can only be used for a single web page, ensuring encrypted access. Defining content security policies. Content security policies ensure that attackers don't inject malicious scripts into web applications to manipulate state changes. Also, hire security professionals or embed continuous security by employing a security scanner and generating a vulnerability report before pushing new production changes. Crashtest security involves a collection of JavaScript scanning mechanisms that enable end-to-end vulnerability assessments for apps, web applications, and microservices with a meager false positives rate. The suite integrates with all modern development stacks to reduce the risk of being hacked through an API or web app. CS Security Scanner also provides downloadable security audit reports you can share with your team or clients. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.